Hey everybody, in this video we are looking at Chapter 1, Section 5, Dimensions of a Square. The length of each side of a square is 3 inches more than the length of each side of a smaller square. So really we have two squares, right? The sum of the areas of the squares is 149 inches squared. I mean, if you don't know, it's 10 by 10 makes 100 and 7 by 7 makes 49 right away. Well, but either way, like it's not about knowing the answer, it's about technique, okay? Because the numbers aren't going to be beautiful numbers all of the time. So let's get into it, right? Find the lengths of the sides of the two squares. Okay, so what do we got? I have a smaller square and I have a larger square. Okay. The length of each side of a square is 3 inches more than the length of each side of a smaller square. So this guy here, if it's a square, right angles, yada yada, all sides are the same, x by x, great. Okay. Then here, if it's 3 inches longer, whatever inches, I already forgot. Yes, that makes this guy x plus 3 and x plus 3, right? Now, the sum of the areas. Well, area is side squared, right? Hence the name square, right? So this area for this first guy is going to be x times x, or x squared. And this area is going to be x plus 3 times x plus 3, which is x plus 3 quantity squared, which I will expand like a diligent, lovely student. And I will get x squared plus 6x plus 9. So that's area of the little guy and area of the big guy, okay? So now the sum of the areas, so I'm going to add x squared plus 6x plus 9, and that sum should be equal to 149. Combine, clean it up, so what do I have? 2x squared plus 6x plus 9. I'm going to write 149 here. I think I have the room for it, yeah. Get it equal to 0. That's what we do, right? 2x squared plus 6x. So if I subtract 149 from 9, you have negative 140 equals 0. Let's divide everything by 2. You can divide by a constant. You just can't divide by a variable to get rid of it, right? So what's left? X squared plus 3x minus 70 is 0. From here, we're going to factor to continue solving x squared plus 3x minus 70. X squared plus, oops, too high. X squared plus 3x minus 70 is 0 is where we left off. What multiplies to negative 70 adds to positive 3. That's going to be x plus 10, x minus 7 when all is said and done. Please remember, we don't use this shortcut unless this is an A. This is an A, unless A equals 1. So here I get x equals negative 10. I can't have a negative side length. And here I'll get, add the 7, x equals 7. So that's the length of the smaller. So the smaller square is a 7 by 7. I'm going to write by because that x looks like, variable, or 7 by 7, and it was inches. And that makes the other one 10 by 10. And there you have it. And interestingly enough, while we're on this problem, if you're still listening, you get a little bonus moment. So back in the day, I maybe talked about this in class, Roman numerals were hard. Math was hard. So if you had to do Roman numeral 3 times Roman numeral 3, like what were you even doing when you dealt with Roman numerals? They're so awkward, right? So what they did is they didn't do algebra the way we do it. They didn't do math algebraically. Instead, they used geometry. They thought geometry was an easier way to solve problems. So when they wanted to multiply 3 by 3, they really set up dimensions of 3 by 3. So that's why we use the x for by for dimensions, right? And then they counted it up. So they were like, okay, how many little squares do I get? Well, I get 9 of them. So they would do Roman numeral 9 for the answer. But when you multiplied something by itself and you used geometry to do it, your shape turned into what we now currently call a square. So it was called squaring, and that's why we call multiplying something by itself squaring. And the same idea when they did length times width times height, basically they were finding the volume of this box when all of them were the same. We called that a perfect cube. So that's why we call multiplying something by itself 3 times, we call it cubed. So that's why they have those nicknames. And that's before the Roman numerals kind of evolved into the numbers we have now, the Arabic numerals. So the more you know. That's your little fun fact of the day. That's it for now. Adios.